Good day, ladies and gentlemen. We are in our sixth lesson, technically, of types of solutions to solving equations, and it's actually going to jump us into what used to be an entire unit called solving verbal equations. So essentially, we used to do a whole unit on solving word problems. We're going to see them all year long, so I'm not going to do as many lessons. I'm just going to give you an introduction as to what we should be thinking. When you're solving word problems, it's important that you translate the word problems into appropriate mathematical expressions and then equations. And to do that, I'm going to ask you to decode the problem. You'll hear me say that a lot this year. And decode means underline, circle, star, all important information and details. You're going to write an organizational let statement. We've seen this once before in writing a let statement by writing the word let and then following up with a bunch of thoughts underneath it. By writing the word let and following up with a bunch of thoughts underneath it, you're actually stating in that phrase that this is what I'm thinking about everything that's going on in this problem. It's generally accepted in mathematics that that is what the word let would be interpreted into. It's important that you try to, when you write an equation from the information you'll be given in a word problem, try and identify any totals. If you're not sure where to start and you have it, a good place to start is with the totals. So that's going to be a neat little trick that's going to help you with a lot of the styles of equations we'll look at throughout the year. You want to check to see if you wrote the correct mathematical description of the relationship. So in some instances, in most instances, it will be an equivalency relationship. But in others, you'll be using word phrasing that will indicate some sort of inequality. We'll talk about that as we go through it. After you've decoded the word problem, you've pulled out some important mathematical facts and written them into mathematical expressions, you'll try and make an equation out of that relationship as described a moment ago, and then you'll try and solve your equation. You want to make sure that your answer makes sense. If you're looking for the age of somebody's grandmother, she shouldn't be negative 42, or she shouldn't be like 5/8. Those would be weird ages. It wouldn't make sense in that instance. You're going to then write a concluding statement with as much description as possible so that we know that you know that what you're talking about. All right, in Roman numeral 1, ladies and gentlemen, I typically have students take a minute or two, well, it usually takes a little longer than that, to decode each of the relationships, and I really want you to put your pen to your paper and try to mark it up a bit. See if you can pull out the important information and connect the muscles in your hand with the ones in your brain. That's a real thing, gross motor memory. So you really want to get writing here. So I would pause the video and I would begin to decode these relationships. I'll do the first one with you that we have a clue about what we're trying to achieve here. 5 less than. We've said this before, and it's important that we say it all year long. Less most often comes last. So we're taking 5 away because we're making it less than whatever's being described in just a moment. The product of 7 and some number. Product means multiply, and we don't know the number. When we don't know the number in mathematics, we typically call it x. So we have 7x, and we often substitute using parentheses. That's a good idea. So less most often comes last, and we're taking that away from the product of 7 and x, so we should have 7x less 5. If you're writing out the relationship, it's really easy to make sure that you did it correctly. You just go and look for the one that is appropriately described. And that would be number 3, which matches the description of the word problem in A. If you have a moment, please pause the video and try to do B, C, and D and see how they align appropriately. If you're done having paused the video and you were able to decode each of the remaining 3 relationships, my hope is that when you had 5 less 7, times the number, the less belong to the description of 7 times the number, and that's what's being taken away from the amount 5. And if that was decoded correctly, that would have been choice 2. In letter C, 5 is less than, and the word is a small word with big meaning. It usually means equal, but it's attached to the words less than. 5 is less than, so that's indicating an inequality relationship. 5 is going to be less than whatever comes next. In this instance, it is the product of 7 and some number. So you've got to multiply, or when we don't know a number in mathematics, we typically call it x, and we're making it 7 times greater, and 5 is less than that. It's possible that this could have been written another way. The algebraic expression could have been on the left-hand side. The numerical constant 5 could have been on the right, and if 5 was less than 7, you'd have to reverse the sign. That way your eye would read it from the numerical constant to the variable term, and although it says 7x is greater than 5, if you read it from the number to the letter, it would be 5 is less than 7x. And that would mean that when 5 less than, less most often comes last, we're subtracting that away. The sum of 7 and some number is decoded. You've got to add 7 and the number and make that entire relationship 5 less. That would have been choice 4. If you have a minute, please take it. Pause the video and see if you can decode the relationships in Roman numeral 2. Underline, circle, star, important information. Try and write out the appropriate expression and see if you can match it with the mathematical sentences or statements described in responses 1 through 4. If you're done pausing the video, ladies and gentlemen, you can take a look and see if your work matches mine. In description A, we have 2 times the quantity n less than 6. Less than 6. Yes, sorry. Excuse me, I got tripped up there. In in description A, ladies and gentlemen, we have 2 times the quantity n less than 6, and that means we're going to be doubling. Less most often comes last. N less means we're subtracting n from 6. Quantity indicates a grouped amount, so we're twicing 6 less n, and that would have been choice 2. Letter B, 2 times n, twice n, minus 6. Subtract 6. That was pretty easy. Letter B should have been response 4. Letter C, everybody, n less. Less most often comes last. That's being subtracted from 2 times 6. So that's 2 times 6 less n. And letter C is response 1. And letter D, if you decode it appropriately, 2 times the quantity 6 less than n. 6 is being subtracted. It's being taken away from n, and we're doubling that quantity, and that should have been response 3. If you have a moment, please pause the video and try Roman numeral 3 on your own. If you've taken a moment to try and decode the relationships in Roman numeral 3, they're a little more complex, but they're certainly doable. Letter A, the description suggests that twice a number. We don't know the number. In our country, typically we call it x. The rest of the world calls a number we don't know n. That seems pretty smart to me. That's twice n less the number. That means we're taking away that variable from twice itself. That's 2n, and we've got a less comes last, so it's coming after, the subtraction of n is coming after 2n. Increase by 5, add 5 to it, is small word of big meaning, is means equals 3. And letter A should have been response 1. Letter B, twice a number, there it is again, 2n, less the number, once again we're subtracting n, then increase by 5, add 5 is 3. That should have been choice B. Looks similar to A, however in A, twice a number less the number increased by 5 indicates that we're subtracting away. I think I missed this a moment ago. I apologize. N, the sum of n and 5. That could have been written better. Sorry about that. Let us see, everybody. 5 more than a number, less twice the number. So we're adding 5 to the number we don't know. We'll call that n. Less most often comes last, twice the number. We're going to have to subtract away twice n from the sum of n plus 5. Is small word of big meaning equals 3. And response C should have been 3. Or description C should have been response 3. Letter D, the difference. Difference means subtracts between a number. We don't know the number. We'll call it n. And twice the number increased by 5. You've got to group those quantities together, and you're subtracting it from n, and description D would have been response 2. These are pretty tough the first time you do them, and when we did this as a whole unit, we would do these several days in a row, and by like the third day, almost every kid got everyone correct. It just takes a little bit of practice, but I really want you to get in the habit of decoding, underline, circling, and starring important information, and writing out the information in the workspace so that you can start to see what it is you're trying to interpret. If all you do is look at the words in the paper, you're going to be confused. Okay, ladies and gentlemen, let's take a look at some of the actual problems. These are some of the more common word problems that show up often in different assessments. They're not all like this, but many of them are similar. And the most important thing is that you practice the steps I'm describing to you. Not necessarily that you get them all right away. That takes a little bit of time. Number 1 wants you to find the sum, so we're adding, of a number. We don't know that number. We don't know a number in mathematics. We typically call it x. Other countries call it n. We want to find the sum of a number and 5 more than the number. So 5 more than the number would be x and 5. Is small word of big meanings equals, and if you know a total, you have a total, start there, 17. What's the number? So I'm going to say let x equal the missing number. And x will have much more descriptive values as we start to talk about and we put these relationships into real world context, but for now it's just the missing number. I've got to add x and itself increased by 5, and it's got to equal 17. And it might not have been a bad idea to have reversed that, to say, Tooch, why don't we start with the total and say the total is equal to x and x plus 5. You could use the associative property to actually regroup this. You could be like, hey, aren't we adding x and x together in the expression on the left? And shouldn't I regroup? Because I can regroup whenever I'm adding or multiplying within an expression. I will not change the value expression. We typically, as lazy students, I hate to say it, but it's true, we typically simplify the expression on the right by just underlining or circling. I don't like circling the like terms. Like terms have the same variable raised to the same power. So x and x together make 2x, and when we increase them by 5, the sum is 17. At this point, we would typically undo order of operations. We had a two-step equation. We would undo addition with subtraction. That way we could determine that twice x is simply equal to 12, and now it's like a joke. You know what the answer is. What number do we double and get 12? Undo multiplication with division, and you find that x should be equal to 6. So, sorry, super sloppy. If x equals 6, we could check our work. That should have been up here. And we should be able to say that 6, substitute in place of x, and 6 plus 5, the quantity 6 plus 5 should equal 17. You can type that expression into your calculator. 6 plus 5 is 11, and 11 plus 6 is 17. 17 equals 17. Yay, we're so smart. We did it. Take a look at number 2. I would recommend that you pause the video and decode it on your own and see if your decoding looks like mine. If you decoded number 2 on your own, I often say that when you read a word problem, you should read it a minimum of 2 times, most often 3 or more. When 3 times a certain number, we don't know that number, we're probably going to call it x, is decreased by 6, that's got to mean we're subtracting 6. The result is, small word of big meaning, that usually means equals, the same as twice the number, that's 2 times x. Write and solve an equation to determine the number. Okay, 3 times a certain number is decreased by 6. The result is equals to x. Write and solve it. Let, not a lot going on here, not super important yet, but it will be, x equal the missing number. Kind of boring to have to write that now, but we will eventually be writing more. So our expression that describes our missing amount is simply x. And our equation is going to suggest that x less 6 is equal to 2x. A lot of different ways you could solve this that would be algebraically correct. What makes this a little bit awkward is that there are variable or algebraic quantities on both sides of the equation, so we'd like to get them to the same side. You wouldn't be wrong if you said, Tooch, I want to subtract 2x's from both expressions. You just have to be careful because when you subtract 2x's from both expressions, it's going to cancel on the right and the relationship will equal 0. And based on yesterday's lesson, that shouldn't freak you out. You could totally have equations set equal to 0. We solve most other relationships throughout the year intentionally equal to 0. But often with linear relationships, first-degree polynomials, we prefer to move or remove the variable term with the lower coefficient. So 1x is less than 2x's, so I would prefer to subtract 1x from both expressions, and I get negative 6 equals 1x. X should be equal to negative 6. Well then, is it true that x equals negative 6, and therefore negative 6 less 6 should be equal to twice negative 6? You'd have to evaluate both the expressions. Negative 6 minus 6 more is negative 12. And when you double negative 6, you get negative 12. Yay, it works. So smart. Cool. Number 3. Number 3, everybody. I recommend that you read and decode it on your own. Pause the video. See if you come up with something similar to me. You should also try and write a let statement at this point, and even your own equation, because you should kind of get the idea of what we're doing here. Ladies and gentlemen, the second of 3 numbers is 3 less than the first. The third number is 4 times the first. If the sum of the 3 numbers is 27, find the numbers. So what's tricky about this is there's more than one missing amount. So because there's more than one missing amount, in our let statement, we're probably going to have more than one expression describing what's missing. The second of 3 numbers is 3 less than the first. The third number is 4 times the first. The sum of the numbers is 27, find the numbers. So they keep referring back to the first over and over again. And what I'm going to suggest to you is if they keep referring to an amount over and over again, I would call that my x. Or if you can identify the smallest amount in a relationship, I would call that x. So that's usually the most efficient way. It's not the only way. So I'm going to call x the first missing amount. Sorry, so sloppy. And we know that the second missing amount is of the 3 numbers is 3 less. Less most often comes last. We've got to subtract 3 than the first. So an expression describing the second missing amount should be x less 3. That's the second missing amount. And then as I continue to read through, I'm going to get some information about the third missing amount. The third number is 4 times the first. So because it's 4 times the first, I can describe it with the variable x. I just have to make it 4 times x. And that would be the third missing number. From all that, once we identify the missing quantities, we're now given a statement that describes the relationship. And it suggests that their sum is equal to, or is 27. So I have a total here, 27, and that's going to be equal to when I add the first number, x, and the second number, x less 3, and the third number, 4x together. To do that, I'd put up a fence. I'd have to simplify the expression on the right-hand side of the relationship. You could drop the parentheses. You could reorder it and write it as 4x plus 1 more x plus 1 more x less 3. That would be using the commutative property of addition to reorder the terms in an expression being added together. We will not change the value of the expression. We'll just make it look different. You could use the associative property and regroup them to make sure that you do that first. Or what we typically do, you could just be like, I'm going to put the x, and the 4x together in the expression on the right. I'm going to rewrite the expression on the right as 6x's less 3. Then you're down to a two-step equation, which requires you to undo subtraction with addition. And then you would undo multiplication with division, or if you prefer, you could multiply by the reciprocal here. You could say that when 30 equals 6x, you'd like to multiply by 1/6. You'd like to multiply by 1/6. That fraction has a denominator. Denominator means divide, and it would actually perform or have the same result as if you were to divide by 6. And in either case, we get x is equal to 5. In this particular instance, you're going to have to go back and say what the three missing numbers are. So if the first number were 5, then 5 less 3 should be 2, and 4 times 5 should be 20. And so that I don't go in a crazy order, I would have a concluding statement. I would say if x equals 5, x less 3 would equal 5 less 3, 2. The second number, and the third number, 4 times x, would be 4 times 5, and that would be 20. And if you check your work informally, just add it up. 20 plus 2 plus 5 is 27. Yay, it works. We're so smart. Flip. Last question, the essential question, the one that you really need to be able to get. Hey, by the way, I apologize for how fast I was writing there. This is a better representation of my work, and I typically say your work should be as neat as mine, if not neater. So as you're working through the video, you have the opportunity to pause as needed, and you should be making sure that your work looks similar to mine in terms of the quality of the work as well as the neatness. So you want to make sure that you are trying to work as neat as possible. I got this wrong in the homework. Look at that. 4x plus 2 more x, as I said, is 5x. Is silly, Tucci. And then when I solved it, I got x equals 6. And when I checked x equals 6, I got 27 equals 33, which isn't true. And I had to go back and redo the whole question again. And I hated my life. Hey, those are my lucky numbers, 27, 33. That's pretty wild. Back to back, right next to each other. Grr. X was not equal to 5. X was not equal to 6. X should have been 5 when I redid the problem. Ladies and gentlemen, the essential question. If you can do number 4, you have a pretty strong interpretation of what we're trying to teach you in setting a foundation for solving word problems throughout the year. You'd have to read the question a minimum of 2 times once to get a general idea what's going on, a second time to extract out the important mathematical information, and possibly a third to make sure you get it together in the appropriate relationship. Mike keeps red, white, and blue marbles in a jar. He has a total of 62 marbles. He has 3 times more red marbles than blue marbles, and he has 12 more white than blue. How many blue marbles does he have? So as I go through this a second time, I recognize that he has 3 different types of marbles, red, white, and blue. He has a total of 62. And then I start to see some information that's going to become important to set up my expressions to describe what's happening in this relationship. He has 3 times more red marbles than blue marbles. And he has 12 more white marbles than blue marbles. And we want to try and find out how many blue marbles he has. So there's a couple of things telling me how I'm going to start to, or giving me a clue as to how I might want to start to write the relationships. One is that we don't know how many he has of any of the marbles. And when we don't know mathematics, typically in this country we call it x. You can call it whatever variable you want, so long as it makes sense to you. We're going to use the let statement to describe all our thoughts about this relationship and not have to write, this is what I'm thinking about, everything that's happening in the question about the marbles. We just write let, and it's generally understood through mathematics that means I'm organizing my thoughts. X has to be something, and it technically could be the red, the white, or the blue. But the easiest way is often to begin to write your statement of the amounts missing, Technically, x could be any of the three colored marbles, but the easiest way to try and identify the expression x so that it will help us to write the relationships appropriately is to try and identify the amount they keep talking about over and over again, or the least amount in the relationship. So once again, they keep referring to blue, and I would call x the number of missing blue marbles. Number of missing blue marbles. And then as I read through it, I can start to identify expressions or create expressions that describe how I want to identify the other missing colored marbles. So he has 3 times more red marbles than blue. Well, that's kind of easy. I just have to triple the blue. So red is going to be 3x. That's going to be number of red. And you should write marbles, but I'm going to keep us moving. And then, as we continue to read, we find that he has 12 more white than blue. Well, that's kind of easy too, because if blue is represented by the expression x, then I just have to increase that by 12, and white should be x plus 12. Number of white marbles. It says that he has 62 in all, and we need to determine the number of blue. If you're not sure where to write your equation at this point, remember, if you're given a total, that's a good place to start. So we know that the total must be 62 total marbles, and we're going to set that equal to the sum of the 3 expressions describing each color marbles. X, which is the blue, 3x, which describes red, and x plus 12, which describes the number of white. From there, we put up a fence. We're going to simplify the expression on the right. We can simplify it by collecting like terms. We just simply have to put together the amount of x variables in total. Since everything's being added, technically we're supposed to drop the parentheses, then we're supposed to reorder. So we're supposed to use the associative property to drop the parentheses, the commutative property to reorder the addition, and the associative property again to regroup them. But we kind of get that we can just add together the like amounts, and the sum would be 5x plus 12. We could then begin to solve by undoing order of operations in a 2-step. We get 50 equals 5x. We could undo multiplication with division, and we could determine that x equals 10. According to what we wrote, that is the number of blue marbles, and we could write a concluding statement that Mike must have 10 blue marbles. In addition to that, it's a good idea to check our work, and if we did that appropriately. So here's a much better presentation, and your work should look closer to this. I called B the number of blue marbles in this particular presentation. 3B was the number of reds, and B plus 12 was the number of whites, and I set it up appropriately, and I actually took the time to reorder the expression and collect like terms appropriately. And then I checked my work by saying, is it true that 62 would be the result of the blue, 10, plus the red, triple 10, plus the white, 12 more than 10, and I typed that into my calculator and said 62, and I felt so smart because I got it right. Your concluding statement should be written neatly and should have detail in it. So I said the number of blue is 10, the number of red is triple that, it's 30, and the number of white is 12 more than 10, it's 22. And if I check it informally and just add them together, I notice that that works as well. Ladies and gentlemen, this is the lesson on an introduction to solving word problems throughout the year. And the most important thing that you could do is to get in good habits. You've got to decode the relationship or the word phrasing. You've got to underline, circle, star important information. You should read it at minimum of 2 times once to get a general idea of what we're talking about. Mike has marbles, 3 different colors. Awesome. A second time to try and identify what's missing and set up an appropriate expressions to describe those missing amounts. And possibly a third time, if you need to set up the appropriate equation. But don't feel like you're behind if you're reading some of these relationships 3 times. That's usually what it takes to put the pieces of the puzzle together. They'll get much more complex, so you want to develop those good habits now. Once you have the appropriate expression, set up an equation. If you have a total, that's a good place to start. You won't always have totals. You'll have expressions equal to one another, other than a numerical constant or a total. But we'll be fine, and we'll get to those in just a bit. Thanks for your attention. I hope you did well, and I will see you in class. Take care.